This is 8.2 notes. As always, the learning target, success criteria, all of this you're going to fill out on your own. This is from our textbook, and you should do that before you do anything else. We're going to start with the vocabulary, stem and leaf plot. So stem and leaf plots are just data display, so it's just a way to display data that uses digits on the right and left hand side. So it takes numbers and it breaks them up by digit. It's useful in some situations. So for example here, if we had the number in the number 83, the 8 would be the stem and the 3 would be the leaf. So again, we'll see how those work generally speaking. If we had a larger number, like a 3-digit number, so like 111 for example, let's use 124. If that was our data piece, the 12 would be the stem and just the 4 would be the leaf. So this is a stem and leaf plot. So each of these numbers on the leaf side represents an individual data piece. So there's 1, 2, 3, 4, 5, 6 different numbers that start with a 2. 20, 20, 21, 22, 25, 27, etc. Example number 1, it says make a stem and leaf plot of the length of 11 fish in inches. So we're going to make a stem and leaf plot. We'll say fish length is our title. We have a stem side and we have a leaf side. I always like to start by making my stems first. So I'm going to come over here and I'm going to look at all my data and I'm going to find the smallest and largest numbers because those are going to tell me what I need to know. So 7 and 25 are the biggest numbers. So I need to use a stem for 7 and a stem for 25. So in order to put the number 7 on there, it's only one digit. So this one's a little bit different than most, but we only have one digit. Well, we have to have something on the leaf side. So in order to represent the 7, I have to have something over here. I have to have one digit over here, and I put all the other digits over here. So whether there's 2, 3, 4, 5, 6 digits, or one digit, I put 1 on the leaf side and everything else on the stem side. So normally I would have like a 1 or a 2 or a 3 here to represent 17 or 27 or 37. But since 7 is just a single digit number, I use a 0. So 0, 7 represents the number 7. Anyway, so back to what I was saying. I try to do the stems first, and the reason I do that is because we never skip numbers on the stem. So from the stem side, our first number here is a 0, and since my biggest data point is 25, I know that my biggest number on the stem side will be a 2. So I can already fill this out. It's 0, 1, 2. And then from here, I'm just going to put the rest of my data on here. I try to do it in order. So the smallest number first, and the next smallest number is 8. So I'm going to put that right next to the 7. I'll put it right there. Now, you can put a comma in there to separate them if that helps you, but typically you don't need it or it's not always there. So those are the single digits. Then we're going to go to all the numbers that start with a 1. So we have a 12, 2 14s, a 16, and an 18. So we have a 12, 2 14s, a 16, and an 18. Next, I have 1, 2, 3 20s and a 25. 1, 2, 3 20s and a 25. And you'll notice that I try to kind of line this up vertically too. So almost like keep your numbers in a grid system. It doesn't have to be perfect, but we want to be able to quickly glance at it and tell there's more fish that were in the teens than there were in the 20s as far as the length of the fish. Additionally, if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers, I should have 11 digits on the leaf side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Finally, the last piece for this is the key. So I'm going to put a key here, and I'm just going to pick any example that I want. Let's say maybe I pick number 14. I'll just put 1/4 equals 14 inches. This key just tells the reader that this does mean 14. In other instances, it might mean like 14,000 or 1,400, depending on what kind of data you were displaying. And also, it's not 14 feet, it's 14 inches. When it's not 14 centimeters, it's 14 inches. So you're conveying that it's inches and that it's this does in fact mean 14 and not like 14,000, for example. Example 2, use the stem and leaf plot of the students' test scores. Part A. How many students scored more than 85 points? So we would realize that all of these represent an individual student, and we know that 85 is right here. So that's 86, 88, 88, 89, 90, 92, 99, 100. So I can just count those. 1, 2, 3, 4, 5, 6, 7, 8. And I would say 8 students. Part B. How many students scored at most 75 points? So that would be 75 or below. So that's right here. So 1, 2, 3. So this person, that person, and that person. 3 students. Part C. What is the median test score? So I'm looking for the middle number. To find the middle number, I just kind of mark 1 from each side as I go. 1 from each side. And then I find that my middle is right here. My direct middle is right in between those 2 digits. This one represents the number 84. That one represents the number 84. So what's in the middle of 84 and 84? Kind of a trick question. It's 84. Example number 3. It says use the stem and leaf plot. Which statements are true and which are false? So it's a true false. We have A, B, C, and D. Part A, it says the range of test scores is 34. So this represents the highest score and that represents the lowest score. This is 100 for 100 and this is 66 for 66. 100 minus 66 is 34. So the range is 34, so that is true. Part B, the mean test score is 85. So I would have to add all of them up and divide by the number of numbers. So 66, 70, 75, 77, 78, 81 twice, 83, 84 twice, 86, 2 88s, 89, 90, 92, 99, and 100. And add them all up, I get 1511, and then count the digits on the leaf side to know how many students there were. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So divide by 18, and it would be 83.94 something. So it says the mean test score is 85. So the actual mean is 80. If you round it, it's 84 or 83.9. But either way, that is false. Part C. The test scores that occur most often are 81, 84, and 88. We have 2 81s, 2 84s, 2 88s. Do we have any digits that or 3 in a row, or any numbers 3 in a row? We don't, so that is true. And then for D, most of the test scores are over 80. So we can see right off just by glancing that all of these and those are above 80. There's only 5 that are below 80, so yes, that's true. Example 4. The table shows the height in centimeters of 11 football players and 11 basketball players. Part A. Make a back-to-back stem and leaf plot to compare the heights of players by sport. So part A, when we have a back-to-back stem and leaf plot, it's just trying to put 2 of them together. So instead of making one for them and making one for them, we kind of just make 2 together. And the only way we can do that is we put the stems in the middle, and maybe we put football players on this side and basketball players on this side. I'm going to look for the smallest, which is that number, and the largest. Let's see, 211 maybe? Which would be that number, 211. So I know that the smallest number is 179. So in order to put that on there, I need a 17 on my leaf. And I think, if I'm not mistaken, yeah, the largest is 211. So I need a 21 to put that on there. So I know I'm going to have 17, 18, 19, 20, 21. Now, I'll start, since I put basketball on this side, I'll go ahead and start with my basketball players, and I'll put all of them on there. 17, do I have any that start with 17? I don't. 18, do I have any that start with 18? I don't. 19, do I have any that start with 19? 1, 2, 3, 4. Yep, so 2, 6, 8, 9. Okay. And then do I have any that start with 20? 1, 2, 3, 4, 5 of them. So I have a 2, a 3, a 6, 7, and 8. 2, 3, 6, 7, 8. The last ones are 210 and 211. So 210, oops, 211. And I can double check myself. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11. That's what the question said, so that's good. Then I'm going to do a similar thing on football. The shortest one was 179, so I'll put a 9 there. And then I'm going to go to all the ones that start with 18. 2, 3 of them. 6, 7, and 8. 6, 7, 8. And this kind of looks backwards, but the only way you can kind of put them together is to put this backwards. So you have to read it as 179, 186, 187, 188. So it is a little odd at first, but that's how we have to do it. 1, 2, 3, 4 in the 190s, 2, 3, 4, and 8, 2, 3, 4, and 8. See, start with 220. We have 1, 2, 3, 0, 2, 6, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 players on the basketball team, 11 players on the football team, or the heights of 11 of the football players and 11 of the basketball players. Part B says, use the stem and leaf plot to compare the mean and median heights of the 2 groups of players. So we want to compare mean and median of basketball players versus football players. We want to quickly glance at this to do so. So they're not necessarily asking us to calculate them. We just want to know kind of roughly what the difference is. And so we can see these are pretty tightly bunched, especially on the basketball side. And so I can kind of look and see, that's my middle number is right there, 203. And so I would say that both the mean and median are pretty close to 203 probably for basketball. And then similarly on football, I can take 5 off one, and it's 193. So I can assume that both the mean and median for football is close to 193. So I'm going to say the mean and median heights of basketball players are about 10 centimeters higher. And I don't even really have to put the 10 centimeters. It's they're just wanting me to compare them. I can tell the basketball players are taller based upon this. Part C. How does the range of heights of football players compare to the range of heights of basketball players? Explain. So football, the largest is 206 and the smallest is 179. So we have a 27 centimeter range. And for basketball, the tallest is 211 and the shortest is 192. So that's only a range of 19 centimeters. So I'm going to say the range of heights for basketball players is less than the range of heights for football players. If we played basketball and football, maybe we could have kind of intuitively known that. Basketball players tend to be tall. They're all tall. Everybody on the team is tall. You have positions, but you don't have as many, and so there's not as big of a variety. Whereas football players, you have kick returners, wide receivers, running backs, offensive linemen, quarterbacks. Depending on your position, it's an advantage to be taller, or sometimes it's not really an advantage, so you just wouldn't necessarily be as tall. So based upon the fact that football teams have more positions or more types of players, you would expect the range of heights to be greater, because there are going to be some tall and some not so tall on the football team, but on the basketball team, they're almost all tall. Oh, one more thing. On our stem and leaf plot, I did forget to put a key on there, so we want to make sure we write that. So I'm going to have a key, and I'm actually going to do pick 2 numbers. So I'll pick maybe this one right here, because we have 192 in both. So I'll do 2/19/2 equals 192 for football and 192 for basketball. Centimeters. Again, you're just kind of showing the reader what those mean. That it's 192 centimeters and it's not 192,000 centimeters or 192 pounds or anything like that. It's in centimeters and it's talking about heights. make sure you fill this out as well as this. Thank you.